When we graph a polynomial function, which is smooth and continuous, we're going to be concerned about two regions of the graph. First of all, the interior behavior. This is where all the twisting and turning occurs. The polynomial achieves maximums and minimums and all of its x-intercepts here. And then the second thing we're going to be interested in is the end behavior. What happens to the polynomial on the extreme left and right sides of the graph? In this video, we'll learn how to predict the end behavior of a polynomial function. Note, while most of the activity of a polynomial function, including turning points and intercepts, occurs on the interior of the graph, the ends of the graph either rise or fall forever. We can predict this end behavior just by examining a special term in the polynomial function. The leading power function, which is the term of the polynomial with the highest exponent, can be used to determine the left and right end behavior of the graph. Now, there will be four possible patterns for the end behavior of a polynomial graph. And we'll break this down into two categories: polynomials of even degree for their leading power function, and polynomials whose leading power function has an odd degree. If the leading power function of the polynomial has an even degree, then the graph is going to have the same end behavior. So in this box, you see two possible polynomials with the same end behavior. In the first box, both ends rise, and in the second box, both ends fall. In the case where both ends rise, the leading power function of the polynomial is going to have a positive leading coefficient. For the leading power function of even degree with a negative leading coefficient, both ends are going to fall. In the other case, we have an odd degree leading power function. If you have an odd degree, then you can anticipate opposite end behavior. Much like our basic cubic parent function, if our leading power function has odd degree and a positive leading coefficient, then the left side is going to fall and the right side is going to rise. And we'll find just the opposite of that with a negative leading coefficient. That is, the left side is going to rise and the right side is going to fall. Let's apply these patterns to example 2. For the following polynomial functions, identify the leading power function and use it to determine the left and right end behavior of the graph. Recall that the leading power function is the term with the highest exponent in the polynomial. So in the case of example A, the leading power function for f of x is x to the 6th power. Observe that this is an even degree leading power function. With an even degree, we can expect the same end behavior. Also notice the leading coefficient is positive. So on the left side, the polynomial is going to rise, and on the right side, the polynomial is going to rise. So whatever the interior behavior looks like for this polynomial function, twisting and turning, doing all its activity, both ends are going to rise. On example B, for the function g of x, our leading power function is the term with the highest power of x. So in this case, that would be negative 3x to the 3rd power. Observe that this is an odd degree leading power function. The O in odd reminds me of the O in opposite, so we can anticipate opposite end behavior. Because our leading coefficient is negative, we can assume this is going to be the opposite of our basic cubic function, where the left side is going to rise and the right side is going to fall. Just think about reflecting that leading power or that parent function x cubed across the x-axis. Now, on example C, we have a polynomial in factored form. In order to identify the leading power function, we would have to execute all of the multiplication and identify our highest powered term. But that's going to be a lot of FOIL, a lot of multiplication. So instead of actually carrying out all of the multiplication, we can just anticipate our highest powered terms. So for example, if I multiply these two terms together, we know that's going to give us x squared minus x. But I'm just interested in the highest powered term. So the highest powered term that comes out of that product is going to be an x squared. And then if we were to FOIL out x plus 2 quantity squared, the highest powered term would also be x squared. And then out of this little linear term, the highest power of x would be x. If I multiply the highest power of x from each product, of course we have to add our exponents here, we would see that our leading power function is x to the 5th. This is an odd degree leading power function. And remember, odd degree leading power functions indicate that the polynomial is going to have opposite in behavior. Also observe that our leading coefficient is positive 1. So this is going to be very similar to our odd degree polynomial function, our odd degree power function x cubed. So again, think about the pattern of x cubed. The left side is going to fall, and the right side is going to rise. All right, one more possibility. We have m of x equals a big polynomial function that is in ascending order, not descending order. When we identify our leading power function, it's not necessarily the first term, it's going to be the highest powered term. So in this case, our leading power function is negative 5x to the 4th. Observe this has even degree. And remember, polynomials of even degree are going to have the same end behavior. Also observe that we have a negative leading coefficient. So let's compare negative 5x to the 4th to the even power function x squared. Okay, x squared is a parabola that opens up, but negative x squared would be a parabola that opens down. It would just reflect that x squared across the x-axis. So my even power functions are going to be similar to the behavior of x squared, just like our odd powered functions will resemble the behavior of x cubed. So notice we do have a negative leading coefficient, so it's going to follow the same pattern as the parabola that opens down. That is, the left side is going to fall, and the right side is going to fall. Now, I hope you followed that logic. It takes a little practice, but once you learn the rules, it's simple. However, if you ever get a little confused or maybe you panic on a test, remember you can easily verify left and right in behavior just by graphing the function on your calculator.